Okay, I guess I am live now. Can people in the chat tell me if my audio is clear? Okay, okay, okay. Okay, I still don't see anybody telling if my audio is clear. Am I audible? I think I am audible. If my audio is clear. Am I? Okay, there seems to be some issue with. Okay, Shang says yes. Okay, can others also tell if I'm audible? Perfect, fine. Okay, okay, okay. I think we should start now. Yes, yes. Audible echo solved only one. Okay, cool. I hope there is no echo now. I have removed that. Okay, can people tell me how many questions they were able to solve? We had a Div-3 round today. I'll just okay. Okay, Pawan says solved only one. Okay. Okay, cool. I see people are responding now. Okay, let's start now. And let's start from the very first question. Okay, so the first question says that Polygraph has 26 tasks. Each task is designated by a capital letter of the Latin alphabet. The teacher asks Polygraph to solve tasks in the following way. If Polygraph began to solve some task, then he must solve it to the end. Without being distracted by another task, after switching to another task, Polygraph cannot return to the previous task. Polygraph can only solve one task during the day. Every day he wrote down what task he solved. Now the teacher wants to know if Polygraph followed his advice. For example, if Polygraph solved tasks in the following order, then the teacher will see. Okay, so I hope like the problem was clear to everybody. So what they're trying to say is in the problem, let's say uh, the order is A, B, B. What this tells is on day one, Polygraph was solving problem A. On day two as well, he was solving problem A. Then on day three, he started solving B, and on day four, he started solving B. He was solving B only. So what this tells us, there is a possibility that Polygraph might have completely solved problem A and then started problem B. But what if we had A here as well? This tells us that Polygraph on day 5 again started solving problem A. And this becomes a suspicion for the teacher, because by this she can tell that Polygraph did not solve the complete problem A on day 2, and we need to avoid that. So basically the solution for this is that we need to have contiguous segments of different characters. So let's say this, we have A here any number of times, then we have X any number of times, then we have M any number of times, and right like this. So basically after I have got a consecutive segment of A, I cannot have A after that anywhere. That is all we have to do. So okay, let me just increase the font so that it's better for everybody. Okay, let's come on to the inputs. So the first input is ABA. Now in this we can see that this A is coming after this B, and we already had an A before this B. Therefore by this we can say that the teacher will become suspicious. So this is not a valid string. Okay, then let's come on to the next example. The next example is D D B B C C C B B E and Z. Now in this, as you can see, we have B here as well, and then we again have B here, which is not right. Therefore the answer for this again will be no. And similarly for the next test case, we have FF G Z Z Y. In this you can see that we do not have, okay, let me just write that as well. So in this we have F F G Z Z Z and Y. Now as you can see, in this we have a consecutive segment of F here, then we have G here, then we have a consecutive segment of Z here, and then a segment of Y here. So what this tells us is that the teacher won't become suspicious, because we only have a segment of F here. After this we do not have any such segment of F. And similarly for this Z as well, and then similarly for this AB as well. Now the way to do this is, we can actually first find out the segments. So through this segment we can actually replace this complete segment to a single F. Then we can just have a single G, then we can just have a single Z, and then we can just have a single Y. Now all we have to do is count that F occurs only once. So let's say we had two F's after Y as well. Now what this would have done is, this consecutive segment would have turned into a single F, and now we can see that we have a count of 2 for F, and by this we could have said that the answer for this will be no. Otherwise, if the F wouldn't have been here, we could have just said that the answer would be yes. So I'll just show you my implementation, how I did this problem. Okay. I hope the logic is clear to everybody, and I'll just quickly show my implementation. Okay. This is problem B. Okay, I'll just copy this because I don't think it is. Okay. Okay, I hope the font is okay with everybody. If it is not, then let me know, or I'll just increase the font. It'll be better. Okay, where do we have font? Okay, just make this as 18. Okay, now I'll just, okay, cool. Okay, so let's look at the input now. So we have t number of test cases. After that we have n for every test case, and then we scan the string. So let's say, okay, let's say that the string was ffg_zzzy. Okay, Yashashvi says no. I think that was for the font. I have already increased that. Okay, cool. So if the font is still not visible, let me know. Okay, cool. So what I'm doing here is, I'm actually having the last as s of 0. So this is the last, and now I'm just iterating from 1 to n. So 1 is this, from this point to the last point. Now I just take, if si equals to last, then I just continue. That means I just skip this f, and then okay, yeah, okay. And if it is not equal, I just increment in m. So m is a map of character and int. So basically for f, I'll have a count of 1. Then I'll move to G, I'll have a count of 1. Then I'll come on to the first Z. This will become my last. This will become my last now. And then I'll skip the Z, I'll skip the Z. Then when I reach this Y, I'll just make Okay, I'll just make this y as 1 as well. Okay, now as you can see, if the count, I'll just iterate over the map. I'm just iterating over the map here. And if the count of this is actually uh, greater than 1, so let's say we had two f's here as well. So what this would have made is this f, the count of this f had would have become 2. And since this is greater than 2, we would have just made a flag equals to 0. And if flag is 0, we are printing no. If flag is 1, we are printing yes. So if the count is less than equal to 0, then the flag remains 1 and we print yes, otherwise we print no. Okay, whole screen, where please zoom the page. I think I have already done that. Okay, can you explain three test case again? Three test case. Okay, I'll just do that. Okay, test case number 3 is okay, this one only. So what I'm gonna do is, this is f f g z z z y. I'm going to break this into contiguous segments. So this segment actually gives me f, this segment gives me g, this segment gives me z, and this segment gives me y. And now I just check if every character in this final string comes a single time only. Okay, I have used ordered set. I don't think that's an issue. You can have an ordered set, unordered set, or whatever. Okay, cool. I hope problem A is clear to everybody. There wasn't much to do in this. So let's just jump on to problem B now. Okay. Okay, I will increase the size of this as well. Okay, so let's move on to ordinary numbers. Let's call a positive integer n ordinary if in the decimal notation of all its integer digits are the same. For example, 1, 2, and so 99 are ordinary numbers, but 719 and 2021 are not ordinary numbers. For a given n, find the number of ordinary numbers among the numbers from 1 to n. Okay, so let's first see what ordinary numbers are. Now, according to this problem, an ordinary number is, it can be either 1, it can be 2, it can be 3, and so on till 9. Then the next ordinary number will be 1 1. Then we'll have 2 2. Then we'll have 3 3, and so till 9 9. Then the next one will be 1 1 1, and so on till 9 9 9. And the last one, so as you can see that n is actually less than 10 to the power 9. So the last one will be this 9 times. So I don't know how to write this. So let's just skip this. So basically the next one will be 4 times 1, then we'll have 4 times 2, and so on till 4 times 9. And similarly, we'll actually have 9 such arrays, if you see. Because we are given that n is actually less than 10 to the power 9. So basically, the last value will be 1, 1, 1, 1. So basically, this is 9 times 1. And similarly for 9 as well. So we'll have 9 times 9 as well. So, okay. I hope this is okay. So the what ordinary number mean in this problem, I hope that is clear to everybody. Okay, now let's see how to do this problem. Now we are actually given 10 to the power 4 queries. So we have 10 to the power 4 queries. Now let's see the total count of ordinary numbers that we have. So we know that for a single digit we'll have 9 ordinary numbers. Now for a number with a decimal notation of 2 numbers, 2 digits, will have 9 numbers again. Then similarly for 3 as well 9, and so on till the very last 9th array, which will again have 9 values. So basically by this we can say that the total count of ordinary numbers is 9 plus 9 plus till this is 9 times. So basically this is 9 into 9, which is actually 81. Atisha says you can write with both hands. No, I'm not writing with both hands. Okay. Okay, so we can see that ordinary numbers, the total count of ordinary numbers is 81. Now, what this actually tells us is that for every query, we can just iterate over these 81 values and check which all are less than n. If anything is less than n, then we just add it to the count and then we print the count. Now, how to generate these arrays? Now, to do that, what we can do, okay, I'll just show how to do that. So what we can do is we can actually generate the very first array, which is nothing but from I to I equals to 1 till I less than equal to n 9, we can just have array I equals to I. So we'll have this array, and so the first index will point to 1, then the second index will point to 2, and similarly for ninth index will point to 9. Now what we'll do is we'll actually take, first we'll check for these values, then what we'll do is we'll take the very first value. So the first, let's say this was x. What we will do is we'll actually multiply this by 10 and then add I into this. So let's see what the first value becomes. So it was 1, so we will first multiply it by 10, so this becomes 10, and then we'll add the index, which is 1, so this becomes 11. Let's see what the next value becomes. So for this as well, 2 into 10, so this becomes 20 plus I is 2, so this becomes 22. Then for the next value we have 3 into 10, so this is 30 plus, and I is 3, so this becomes 33, and so on. We'll get 99 as well. Now for the next array, we can actually use this array now, so and do the same thing. So now x is 11, so 11 into 10 is 110 plus, and I is 1, so we'll have 1 here, so this will actually become 111. And the next value also, so we'll have 22 into 10, which is 220, plus I is 2, so we'll have 2, and this will become 2, 2, and 2, and so on. So using this method, we can actually generate the complete array of ordinary numbers. And then for every query, we can just check if the count of ordinary numbers which are less than n. If a value is less than equal to n, then we just add it to the count. I hope the logic is clear to everybody. I'll just show the code. Okay. Okay. So let's see the code now. So let's see what I'm doing. So basically, for every test case, what I'm doing is I'm actually generating the very first array, which is 1, 2, 3 till 9. So I have an array of size 10, and from I equals to 1 till I less than equal to 9, I'm doing array I equals to 1. Now array I equals to I. So basically, this is going to generate this very first array with indexes 1, 2 till 9. Now what I do is I'm actually just running it while k is less than 11, because we know that in total we'll have 9 arrays. So I just wrote it k less than 11. You could also have k less than 9 as well here. Now for every k plus plus, I'm actually using the previous array that I had. So basically I had this array. I'll just count for this array first. I'll just check if n is greater than equal to array I. If it is, then I'll just make count plus plus. Otherwise, what I'm going to do is I'll just make array I into equals to 10. Okay, for n, okay, so I'll just make array I into equals to 10, and then I'll just add array I plus equals to I. So this is what I'm doing, x into 10 plus I. With this, I'm actually going to generate the any index value to the index value of the next array. So I'll just run into this while loop. I'll count all the values and just print the count. Lakhan says for n greater than 9, can we do 9 plus n by 11? Okay, let's see if this is right. Okay, so 9 is for, okay, those values. Then let's say we count for 330. So this actually gives us 330. So this gives us 30. Let's see if this is right. So we'll have, okay. No, I don't think this is right, n plus n by 11, Lakhan. Because let's see for, okay, let's see, I'll show. Let's say n is 330. So your answer is going to be n plus 330 by 11, which is actually 30. Right. Let's see if there are actually 30 numbers. So we'll have from numbers from 1 to till 9. Then we'll have 11 till 99. Then we'll have triple 1, triple 2, and that's it. We cannot have 333 because that is actually greater than 330. And now if we count, this is like 9 numbers 18, 19, and 20. So basically the answer should be 20. But from your formula we are getting 9 plus 30. So Lakhan, I hope you know why your solution is wrong. Okay, so cool. I hope this solution is clear to everybody. If anybody still has any doubt, they can let me know in the chat. I'll just explain the complete process again. If not, we can move on to the next problem. Okay. Okay. Okay, Lakhan says yes, yes, and okay, cool. Perfect. So let's move on to the third problem now. And the third problem says that we'll consider the number a and b as adjacent if they differ by exactly 1. That is mod of a minus b equals to 1. Okay, cool. We'll consider cells of a square matrix n into n as adjacent if they have a common side. That is for cells R to C. Okay, so basically we have a matrix of n into m. Let's say this is the matrix. Let's say we are at this particular cell. Then this cell is a neighbor, this cell is a neighbor, this cell is a neighbor, and this cell is a neighbor. So basically every cell that is sharing a side is a neighbor. Okay. Okay. For a given number n, construct a square matrix n into n such that for integer from 1 to n square occurs in the matrix exactly once. If R1 and R2, R1C1 and R2C2 are adjacent cells, then the numbers written in them must not be adjacent. Okay, cool. So basically what the problem is telling us is that we'll have to make, okay, the array is of n into n only. Okay, so we'll just remove this. So basically for an n cross n array, we just have to insert all the numbers from 1 till n square in such a way that no adjacent cells have any value which is adjacent to each other. So basically the mod of a minus b should not be equal to 1. Okay, okay, and we have t is actually 100 only, so we don't really have to care about that, and n is 100. So if we see, we'll have a matrix of n into n, so basically that will take 100 into 100, and this is actually, okay, 100 n square, and for every test case we'll have 100 as well. Okay, so this complete comes out to be 10 to the power 6. Okay, cool. So let's see how to do this. Now if n equals to 1, we can just say that the matrix will be of size 1 plus 1 only, and we can just insert 1. Now let's see for n equals to 2. Now if n equals to 2, let's try to draw this array. Now let's place 1 anywhere. If we place 1 here, then we cannot place 2 here because this cell is adjacent to this one, and we cannot place 2 here. So the only place where we can put 2 is this. Okay, now let's come on to 3. Now we only have 2 options left. So if we put 3 here, this 3 will become adjacent to this 2, therefore we cannot do that. And if we even try to put 3 here, this 3 will become adjacent to again this 2 only. So with this, we can actually see that the answer for this test case will be -1, as there is no way to place the values. Now let's come on to n equals to 3. Okay, so let's make a 3 cross 3 array. Now what we're going to do is we're actually start inserting the values any, like in the order they can be placed. So let's say we place 1 here. Now which is the next cell where 2 can be placed if we iterate this matrix? So if we actually try to place this 2 here, this 2 will become adjacent to this one, so we cannot put it here. Now let's talk about this cell. If we see, we can actually put 2 here because this 2 is not adjacent to this one, and all the other cells are unfilled at the moment. Now let's come on to 3. So we can put 3 here as well. Okay, we can put 3 here as well, but okay, let's say we put 3 here. Now let's come on to 4. We cannot put 4 here, so we'll just let's come on to the next value, which is this only. So let's try to put 4 here. If we try to put 4 here, we see that it is not adjacent to anything which has the value also adjacent to it, so we can place 4 here. Now let's come on to 5. We can place 5 here, then 6 cannot be placed here, so we'll place 6 here. Now the rest values are 7, 8 and 9. Now as you can see, if you place 7 anywhere, the next value will not be able to place. Now in order to solve this, you actually need to realize a very a pattern. So if we see, when we were placing 3, we can actually place this 3 here and just keep on placing the values alternatively, because we are given that we do not have to so the adjacent values should not be having in the adjacent cells. So what we can do is we can actually have adjacent values. So basically 1 and 2 are adjacent, so we'll just skip one cell in between. Now 2 and 3 are adjacent, so we'll just skip one cell in between. Then again for 4, we'll just skip one cell in between and we'll place 4 here. Then again for 5, we'll just skip one cell in between and place it here. Now what we are going to do is we are again going to start from the very starting and place the rest of the values. So 6 will come here, 7 will come here, 8 will come here, and 9 will come here. Now if you see in this matrix, no adjacent cell has an adjacent value. So I'll just show this very thing again for n equals to 4. Maybe it will become more clear then. So let's say n is 4. Let's have a matrix of size 4. Okay, so we are going to follow the same approach. We'll have 1 here, we'll skip one index and then put 2 here. We'll again skip one cell and place 3 here. We'll again skip one value, we'll place 4 here, then 5 here, 6 here, 7 here, and 8 here. Now we are going to place 9 here, 10 here, 11 here, 12 here, 13 here, 14 here, 15 here, and 16 here. I'll just have the array of 3 cross 3 as well so that everybody can see how the pattern is becoming. So for 3, what we had was, so let's say this is n equals to 3. So we have 1 here, then we have 2 here, we have 3 here, we have 4 here, 5 here, 6, 7, 8, and 9. Mohammed says first fill the odd values and even values after. Exactly, that is what we're doing. We're actually skipping one index, which is actually like true for odd and even. Yeah, exactly that. Okay, cool. Okay, I hope the logic is clear and the pattern is clear to everybody. We can fill all the even values first and then, yes, exactly, Milan. Okay, so I'll just show how I wrote the code for this. Maybe that is, so the reason I'm showing the codes is so that you can just see how you can implement this. Now these might not be the best codes, but yeah, that is one way to implement this. Okay, so let's see. So basically what I did was I actually made an array of n into n and I had a value of flag equals to 1. Now I had k equals to 1, which is actually the value that I'll be putting in every index. Now I have hard coded that if n equals to 2, we can just print cout minus 1, as we saw that for 2 we do not have an answer. Now let's come forward. So what we are doing is I'm actually iterating in the array, and if my flag is 1, so right now my flag is 1, so basically array 0 0. So I'll just show this to you for n equals to 3. Okay, so I'll just make 0 1 2 0 1 2. My I is this side and j is this side. So when my I and j are 0 0, my flag, okay, I'll just make flag as well. So my flag is actually 1 at the moment. Now if my flag is 1, I'll make array ij equals to k. My k is 1 right now. So I'll just place at 0 0, I'll place 1. The next thing that I do is I'll just change my flag from flag equals to 1 minus flag. So basically this will become 1 minus 1, which is actually 0. So my flag now becomes 0. My k becomes k plus plus, which is 2, and I move forward. So when j equals to 1, I see that my flag is 0. So I do not go into this if loop. Then I again change my flag to flag equals to 1 minus 0. So this becomes 1 minus 0, which is 1. So this flag is 1 now. Now when this j becomes 2, okay, when this j becomes 2, I can just, I now see that my flag is 1. So if my flag is 1, I make array 0 2 equals to k. So basically 0 2 equals to k. K was 2 right now. I place k here and I then increment k. So this becomes 3. Okay. Now let's, my flag will change from 1 minus 1. So this becomes 0 again. So this is 0. Now if you see, my I will increment. I will become 1 and j will become 0. Now I'll see that my flag is 0. Therefore I'll just skip this value and make flag equals to 1 minus 0. So this will become 1. And now again when j equals to 1, I'll place this k here. So I hope the pattern is clear to everybody. Now through this nested for loop, I'm filling the odd values, I would say. And then from the next for loop, I'm actually filling the even places. So that is how I did it. And then I'm just printing. So maybe this is one implementation you might find good. Or else I'm pretty sure there are other implementations for this as well. Okay, I hope the logic is clear to everybody. If it is, we can move on to the next problem. Okay, so let's move on to the next problem now. Okay, just give me a second. Okay, cool. So let's go to the next problem now. So the next problem says that you're given an array A of integers. Count the number of pair of indices ij such that I is less than j and aj minus ai equals to j minus I. So basically, what they are telling us is that this is our array. Now, let's say this is I and this is j. Now, what they want us to do is that I should be less than j and aj minus ai should be equals to j minus I. And that's it. So basically, we just need to find the number of pairs of I and j possible. Okay. So, uh, so this is actually a pretty standard problem and a very like well-known problem. So if you were not able to do this problem, I would say that's perfectly fine because this is a very standard problem which if you know, you'll be able to do every time. And there are many multiple variations of this problem as well. So if you know this problem, you can actually solve other variations as well. Okay. So let's see the very first problem. We have 3, 5, 1. Okay. So let's see. Okay. What I'm going to do is I'm actually going to change this equation to, okay, so I'm going to change this to aj minus j equals to ai minus I. All I did was I just changed the indexes to the other side. So basically what this actually tells us is that if I actually decrease the index value from the value, then this value should be equal to some other value as well. So actually this is the solution only. All we just have to do is, so let's say, let's take the this last input. So let's say we have 1, 6, 3, 4, 5 and 6. And let's write the indexes. So this is the index 0, this is 1, this is 2, 3, 4 and 5. Okay. So what we are, so we know that the value of aj minus j equals to ai minus I. So basically all we have to do is we actually have to decrease the index value. So 1 minus 0 is 1 only. 6 minus 1 is 5. 3 minus 2 is again 1. 4 minus 3 is again 1. 5 minus 4 is again 1. And 6 minus 5 is again 1. Now what this tells us is that we can actually, so basically we can take this value or this value, this value, this value or this value. From any of these 5 values, we can make any one index as I and the other index will automatically become j. Any other index will become j. So by this what we can say is we just have to see the count of 1. So basically we had 1 at 5 places. So we had 5 places and we need to take I and j. So basically we need to choose 2 places out of these. The first place will become I, the second place will become j. So basically the answer is 5c2. Now 5c2 is actually 5 into 4 by 2, which is 10. And as you can see, the output for this is 10. Let's see some other example. Let's say, okay, let's say we took the third example. We have 1, 3, 3 and 4. The indexes are 0, 1, 2 and 3. So this becomes 1 minus 0 is 1. This becomes 3 minus 1 is 2. This becomes 3 minus 2 is 1. This becomes 4 minus 3 is 1. Now as you can see, we have 3 ones here. So we'll have 3c2 and then we just have 1, 2. So this will actually contribute to 1c2. Now 3, okay, I need to remove my picture. Okay, so 3c2 will actually give us what? 3 and 1c2 will give us 0. So 3 plus 0 is actually 3 and the answer for this test case is hence 3. So that is all you have to do. You just have to take the array, decrease the index values from every position and then count how many how many similar values we have, and this, and for every value we just have to find, like, choose 2 values. So I'll just show the code. Okay. This is problem D, right?  。  . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . 。 . . 。 . 。 . 。 . . 。 . . 。 . 。 。 . . 。 。 . . 。 . 。 。 . . 。 . 。 . 。 . 。 . 。 . Okay. Okay, cool. So let's see the code. For every test case, I'm scanning in and I'm scanning the complete array. So this is the complete array. I'm changing my array value to array I minus equals to index. So basically, I'm just removing the index value from the index. And then I have a map. So in map, I'm actually storing the count. So in this map, I just make m of array I plus plus. So basically, in the end, after this for loop is over, we'll have the count of every value. And then after this, what I do is I just have an answer equals to 0. And then for every value in the map, I just do. So basically, nc2 is nothing but n into n minus 1 by 2. So that is what I'm doing. I'm just doing it dot second is actually the count. So count, so this is the count. Count into count minus 1 complete divided by 2. So I'm adding that into the answer and then I'm just printing the answer. So I hope this problem is also clear to everybody. This was a very standard problem. So I hope like for the people who didn't know this, this is something good to learn. Okay, cool. Okay, can people in the chat tell me if they are clear with the A, B, C, and D, so that we can move ahead to the rest of the problems. Okay. Okay, and I'll take that time to actually show a little bit about Unacademy. So the first thing that you can do is you can actually go to unacademy.com/@naman1013. Naman1013 is my handle. So you can just go there and follow me so that you can actually have access to all my special classes that I do. So right now I'm actually doing special classes on the very basic topics that are like two-pointer, binary search, greedy algorithm, that and such stuff. And then okay, so that is all about me. I'll just tell a little bit about me as well. Okay, so I'm actually working in Adobe as a software developer. Before Adobe, I was working in DShaw as a member technical. Then on Codeforces, I am a candidate master, and on CodeChef, I'm 5-star. So I'm actually like teaching competitive programming, data success algorithms, and I'll also be having some videos related to interview preparation as well. So make sure that you follow me on Unacademy. Apart from this, so what Unacademy is actually doing is it is actually organizing live interactive classes like this one. Then you also get practice problems which we the educators make from CodeChef, and you also get doubt support from us. This is the subscription plan. As you can see, the 12-month program is the best one. As you can see, the per month amount. Now, the something good that I have is that you can actually use my referral code, which is NBYT, and you'll get a 10% discount. So make sure that you use my referral code if you're getting the subscription. And that's it about the subscription. And I hope ABCD are clear to everybody so that we can move to problem E. Okay. Okay, can people in the chat tell me how many people were able to do till ABCD? We have 48 people watching right now. Let's see how many people were able to do. Okay. Okay. Can you explain once why 5C2? Okay, so the reason why we are doing 5C2 is we saw that 1 was occurring 5 times. So we can choose any of these ones as I, and we can choose any other index as j. So all we have to do is from out of all the values, we just have to find out uh, any two values. And the total possible such pairs are actually like nc2. So basically, if we have a count of n, and the possible ways to like take up any two values from those n is nc2. Pawan says why we hadn't done nc2. We are actually doing nc2 only, but here n is actually the count of any single value. So like we saw that the count of 1 was 5, therefore we did 5c2. Okay, I hope it is clear to Pawan and Abhi now. Okay, cool. Okay, Pawan says clear, sir. Okay, perfect. Okay, let's come on to problem E now. Okay, so you're playing the game arranging the sheep. The goal of this game is to make the sheep line up. The level of the game is described by a string of length n, consisting of the characters dot, which is an empty space, and star, which means sheep. In one move, you can move any sheep one square to the left or one square to the right. If the corresponding square exists and is empty, the game ends as soon as the sheep are lined up. That is, there should be no empty cells between any sheep. For example, if n equals to 6 and the level is described by the string star star dot star dot dot, then the following game scenario is possible. So the sheep at position 4 moves to the right. So basically at position 4, we had the sheep and this moves to the right. So basically this moves to the index 5. Okay. And similarly other moves are also given. For a given level, determine the minimum number of moves you need to make to complete the level. Okay. Samrat says it is illegal to solve the CP problems. I don't know what you mean by this, Samrat. Okay. Okay, so let's see, we have 10 to the power 4 test cases, and every test case has n, which is of till 10 to the power 6, and sum of all test cases does not exceed 10 to the power 6. So let's say we had a test case. Let's have the very first test case. So we have star, sorry, we have star, 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 empty space, star, empty space, empty space. So as you can see in this, all we have to do is we just have to shift this sheep at fourth index to the left, and with this actually makes star, 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 and empty space, empty space, empty space. Now we can see that all the three sheeps are actually together. Okay. Now and that's why the answer for this is 1. Similarly, let's see in this. Okay, let's take the last test case, which actually has 10 values. So we have star, empty space, star, empty space, empty space, empty space. We have star, empty space, star, and star. Okay. Okay. So basically, in this, let me see like the where do we get the final answer so that I can show the number of moves. Okay. I hope this. I think this is the answer. So basically, this is 3 plus 2 plus 2 and this, yes, correct. Okay. So basically, the answer for this is actually we can have the first ship at this index, the second at this, third at this, fourth at this, and fifth at this. Let's see the distance now, the cost that we actually get. So basically, the first sheep comes to here. Now, obviously, the best possible way to bring the first sheep here is to take the very first sheep in this string as well and take it here. Because if we take any other sheep, let's say we took this sheep, then the cost of taking this sheep to any other place would be much greater than the cost of taking the sheep till this index. Therefore, we always have to maintain the order of the sheep. So for this sheep, we actually bring it here. So this costs us 1, 2, and 3. So this costs us 3. Then this sheep will come onto this index. So this costs us 2. Then this sheep will come onto this index. So we'll have a cost of 1. Then the next sheep, which is here, will move to this index and will cost 2. Then this sheep will move on to this index, which will again cost us 2. And the sum of this is 10. As you can see, the answer is 10 also. Now, how do we find out the optimum value? Let's say we had an array. Okay. Let's say this was the array, and at any random places we had all our sheets. What we need to do is we actually need to have a left array for this and a right array. So this again is actually a pretty standard problem. If you once see how this is done, you'll be able to do any problems which are similar to this or are some variations of this. So because this is also a standard problem and many variations of this problem exist. So what you need to do is you just need to select any index. Let's say we are at this particular index. What you will do is you will make sure that all the values on the left are right here. So you'll find the cost of getting all these values here, and all the values on the right, you'll try to place them on exactly on the right position. So this will have a cost of y, this will have a cost of 1, x, and this will have a cost of y, and you'll say that the total cost is x plus y. But something problematic here is that you have all the sheaves here of the left direction, you have all the sheaves here in the right direction, but this space remains empty. So in order to solve this, what you need to do is you actually need to take two indexes. Okay, let's say we took these indexes. Let's say our sheaves were okay, we had one sheep here and one sheep here, and in the right direction we just had one sheep here. Now if you see, what I am trying to do is I'm actually trying to bring the left sheaves here exactly at till this index and the right sheaves at this index. So what I do is I see that I have two sheaves. I just place them, both the two sheets in this in the left direction from this index, and I place all the sheets that are in the right direction from this index. Now let's see the cost. So basically the cost for this particular sheep to reach this index is 2. The cost for this sheep to reach this index is 1. And the cost for this sheep to reach this index is 3. So what we need to do is we actually, for every index, we need to find the left value, which actually means that the sum of all the values that all the sheeps need to move in the left direction to have. So basically if we are at this index, what this means is the left of this index will be actually have all the sheeps starting from this index in the left direction. And similarly for the right direction also we need for every index. Now how to calculate this? Okay, so let's see the left value for this index. We know that the left value for this index is 0 because we had a sheep here and we want to place this particular sheep at this in the left direction only starting from this index. So since we had one sheep only, we'll just place it here. Now let's come on to this index. If we wanted to place sheeps in the left direction from this index, we can see that there is only one sheep in the left and that will actually come here, and the cost for that will be 1. So we just put 1 here. Now let's come on to this index. We now see that we have two sheeps. Since we have two sheeps here, we will actually place the sheeps, one sheep here and the other sheep here. Now how to do this? We know that the previous index will have the way to keep all the sheeps at this index. Now since this is also a sheep, we can just keep this sheep here and we can actually just put the value of left of I minus 1, because we know that we already had a sheep here, and so basically this index is covered. Now the previous index needs to cover all the sheeps on its left direction, and that is already calculated in left of I minus 1. So basically what this means is left of I minus 1 is 1, so basically we can just write 1 here, which actually tells us that we keep this sheep here only and we just move the sheep to the right direction by 1 step. Okay, now let's come on to this index. Now what this index tells us is that we do not have any sheep here. What this means is, so let's say, so basically this is left of I minus 1 right now. This left of I minus 1 actually tells us that we have all the sheeps from this index in the left direction. Now if we would anyhow be able to tell the count of these sheeps, because we know that there are two sheeps. Now in order to have these two sheeps shifted by 1 step, since this is empty, we actually have to move every sheep by 1 in the right direction. So actually what this does is plus count of the sheep that we had in the left direction. Now left of I minus 1 was already 1 and the count of the sheep was 2, so we just write 2 here, and this actually becomes 3. And as you can see, this sheep will take 1 cost in moving from this index to this index, and this sheep will take 2 cost from moving from this index till this index. And we can actually have the similar approach for the right as well. One way would be we can just reverse this array and then find the right index, or we can just have a reverse for loop as well. I hope this like the way to find the left and right index is clear to everybody. If it is not clear, you can let me know in the chat. I'll just explain everything again, because this is something that you need to understand, and it is very useful at many places. And also, like, this will become very clear when I show the code. So let's just move on to the code only, so that I can show like how to implement this. Okay. Okay, it is not opening. Okay, cool. Okay, so let's look at the code now. Okay, cool. So what I'm doing is, I'm for every test case I'm scanning in, I have array of n plus 1. So I'll just tell why I did this n plus 1. And also to do that, I'll just take a test case as well. So let's take this first test case only. Okay. Okay, Pawan, I'll explain once again through the code. If you're still not clear, you can let me know. Okay, this is of 6 size. Okay. And we have here. Okay, Atisha says repeat. Okay, cool. Saran says, which college are you from? I am actually from JP Noida, sector 62. I don't know if you people know about that college. Okay, so let's see the code. What I'm actually doing is, now the n was 6. I actually made an array of array 7. So this is 0, 1, 2, 3, 4, 5, and 6. I'll briefly explain like why I took array of n plus 1. Okay. So now I again make another array which is again of size 7, and this is my left array. Okay, so this is my left array, and this is index 0, 1, 2, 3, 4, 5, and 6. Now what I do is, I have count equals to 0, so our count right now is 0, and left of 0 is 0. Now let's see what I do. I do I equals to 1, I less than equal to n, I plus plus. So basically I'm moving from I equals to 1 till I equals to 6. Okay, cool. So let's see what happens. So it says that if array I equals to star, we know that this array I is star. So basically we move into this if loop, and we just make left of I equals to left of I minus 1. So basically we just see what left of I minus 1 is. This is 0. We just write it here, and we increment our count. Okay, let's move on to I equals to 2. When we move on to I equals to 2, we again go into this if, because array I equals to star. What we do is, left of I equals to left of I minus 1. So basically this again becomes 0, and a count becomes 2. Let's move on to the next index. When I equals to 3, we see that array I is not equal to star. Now since this is not equal to star, what I do is, I do left of I minus 1 plus count. Now let me tell why I'm doing this. So basically this left of I minus 1 is telling me the cost if I had to place all my sheep one index before this. So basically, as you can see, we have 2 sheeps here. Now this count actually tells me the cost I need to pay to move all these sheeps one step in the right direction. So basically we had 2 sheep, so we'll have to, like, we'll move this sheep by 1 and the sheep by 1. So therefore this becomes left of I minus 1 plus count. As you can see, we have left of I minus 1 plus count. And if this was a star, so basically when this was a star, we know that we do not, so basically no sheep needs to come on this index, and we just need to arrange all the sheep before this index adjacently to the left direction, which we already had in left of I minus 1. So basically that is why we just had left of I equals to left of I minus 1, and if there was no sheep, then we had left of I equals to left of I minus 1 plus count. So basically what this 3 will have is, left of I minus 1 is 0, the count is 2, so we'll have 2 here. Then again, let's come on to index 4. So we know that this is a array of I equals to star. So we'll just have left of I equals to left of I minus 1. So this again will become 2. Now you can even see that. So basically this sheep stays here, this sheep will have to come one place here, so the cost will be 1, and the sheep will have to come one place here, so the cost will be 1, and the total cost will be 2. So we can say that this formula is right. Then again for 5 also, now since this 5 is actually, we again increment the count to 3, and this actually RA5 becomes left of I minus 1, that is 2, plus count, which is 3. So this becomes 5, and if you actually see, the cost will also be 5, as this sheep will come here, so the cost will be 1. This sheep will have to come here, the cost will be 2, and this sheep will have to come here, the cost will be 2. So 2 plus 2 plus 1 is 5. And similarly for this index, we'll have 5 plus count, so this is 3, which actually makes 8. So this is how we made the left array, and similarly we'll have the right array as well. I will not show the how I'm calculating the values for the right array, because you can just reverse this array and populate the right array, or you can just have a reverse for loop, which is what I did. So the values here will be 0, 0, 0, 1, 1, 1. Okay, this is what this array will hold. Okay, now what I do is I actually start from I equals to 1. So I'm at I equals to 1 till I less than n. So basically I move till 5 only. Okay, and what I do is I find the minimum value of left I plus right I plus 1. The reason why I'm doing this, so basically if I take left of I of this and right of I plus 1 of this, what this tells is I'm actually having all the sheaves which were in the left direction from this index stored at this consecutively at this index, and all the sheaves that were at in the right direction from this index, I'm storing all of them consecutively from this index. So what this tells us is I'll actually have a complete consecutive segment of sheep. So this is how I'm just iterating from I equals to 1 till n. Now one thing that you need to keep in mind is, which even I forgot, and that is why I got a wrong answer and my first submission. You even need to see this also. So basically right of this, because this is the very first index, and we will actually have all the sheep on the right direction of this or on this index. So this is also one possible answer, that we can actually have all the sheep in the very starting, or we will also have to check left of n as well, because we can also have all the sheep at the very end. So you need to add these two lines as well, and then you can just print the minimum value. I hope this code is clear and the logic is clear to everybody. This again was also like something which is very popular, and something related to prefix arrays and a little bit of DP or greedy, whatever you say. Okay, I hope this is clear to everybody. If it is, we can move on to F1 and F2. Okay, can I have a yes from people in the chat? Okay, cool. So let's move on to F1. We'll first solve the easy version. I'll have everything according to easy version, and then we'll come on to the hard version. Okay, Gaurav says, can you explain last two lines? Okay, I'll just explain them again. Okay, so what I was doing in the last two lines was, so basically when we had this left array and when we had this right array, we were only having, so basically what we assumed was left of I and right of I plus 1. But what we can also have is that there is nothing in the left and every sheep is in the right direction only. And similarly for the left also, that there is no sheep in the right direction, but all the sheep are on the left direction. So that is why we need to consider right of 1, that every sheep is on the right of the first index, or every sheep is on the left of the last index. That is why we took answer comma right 1 and left n. I hope this is clear to Gaurav now. Okay. Okay, cool. Okay, let's come on to F1. Okay, cool. So let's move on to F1. Polygraph is playing a computer game. In this game, an array consisting of zeros and ones is hidden. Polygraph wins if he guesses the position of the kth zero from the left t times. Polygraph can make no more than 20 requests of the following type. Question mark LR. Find out the sum of all elements in position from L to R inclusive. And so basically in this, it is given that t is equals to 1 only for the easy version. So let's skip this paragraph. And so this is the interaction, how we are going to interact. So I'll just explain from the input only. So what they are telling is that, let's say the array was 1, 0, 1, 1, 0, 1. The indexes are 1 base, so 1, 2, 3, 4, 5, 6. Okay, cool. Okay, so what they're actually telling is that, so this 6 and 1 are actually telling us that n is 6, t is 1, t is always 1 in the first, like in the easy version, and then we have k is as 2. So basically we need to tell the kth 0. So as you can see, the kth 0 is actually this 0, and as you can see, the answer is also exclamation 5. Let's see the queries that they are doing. So I'll just write all the queries. So we have query 46, we have query 11, we have query 12, we have query 22, and we have query 55. And for every query, I'll write the answers as well. So we have, this is the answer, 2, 1, 1, 0, and 0. Okay. So as you can see, from index 4 to 6, so this is 4 to 6, we have 2 ones. So this actually returns us 2. Then from 1 to 1, we actually have 1 1 only, so the answer is 1. Then from 1 to 2, we have 1 1 only, so the answer is 1. From 2 to 2, we have 0 1. And from 5 to 5, we have a single 1. From 5, sorry, this is 5. From 5 to 5, we have no 1, so this is 0. This is the input that we have. And now we need to, so basically we had to find out the index of the kth 0. So as in this case, the index is this. Okay, cool. So there is one thing that I would like to tell everybody, that like in, at least in my case, like almost 90% of the problems that I have, interactive problems that I have done, are binary search. So like whenever you are doing an interactive problem, just keep in mind that like there is a very high probability that the problem will be solved using binary search. Okay, so let's look at the maximum queries that we can do. So the maximum queries are actually, so we have how many queries? 20 queries. And the maximum length of n is actually 2 into 10 to the power 5. Okay, cool. Okay. So the way we can do is that, okay, let's say this was our array. And let's say at any particular index, I told you that we had x number of ones. So let's say this index was n. Now what we can do is we can actually find the number of zeros still here as well. If we are given number of ones, then through that we can actually find the number of zeros as well. The number of zeros will be m minus x. M is the total values and x is the values which are 1. So basically zeros will be this and ones will be x, and the total size is m. Now let's say we had to find k, and we know that this k is actually greater than m minus x. Now if this k is greater than m minus x, we know that our answer will lie somewhere in this region. The next thing that we can actually do is we can actually take the middlemost point and again find this x. So again we'll have m minus x as the count of zeros. And now if we see, let's say that this k was less than m minus x. If this was less than m minus x, we know that our answer lies somewhere here in this range. Then again we can have the middlemost element and then do this. So as you can see, this is actually binary search, because we take one index, we check how many zeros we have till that index. If our answer, like if the required number of zeros are greater than that, we move on to the right direction. If the number of zeros are onto the left lesser, then we move on to the left direction. So that is all what you have to do. I'll show the code to so that you can see how this is implemented. Today's Div-3 was actually like very interesting. All the problems were very standard, And like for people who are like starting out, there are many new things to learn for them. Okay, so I'll just bring my code. Okay, I hope the logic is clear to everybody. People in the chat, can you please respond like if you understood the logic? Okay, I didn't copy, I think. Okay, okay, cool. Shiva says, how can I develop recursive thinking? Okay, the way I did is I actually did binary trees. So you can just like look into all the binary trees questions, like how to find if any two binary trees are mirror trees, how to find the sum of a binary tree, how to like find from root to leaf paths and everything. If you do all the questions of binary trees, like you will get a very good understanding how recursion works. Like at least in my case, that is how I did. Otherwise, the other cases like you can actually like solve problems related to recursion or DP. But I think like this is something that becomes a little harder for people. So maybe you can give this approach a try. Okay. Okay, cool. So let me just explain the approach, what I'm doing here. Okay. So basically, this is a very standard way of writing binary search. And like for people who are actually like very new to binary search, you can just use this code anywhere. Like this is the very like standard code which works everywhere. Okay. So what I'm doing is for every test case, which is like for the easy version, this t is always equals to 1. So this while loop will run only once. What I'm actually doing is I have fixed my L to 1 and R to N in the start. So let's say this was my complete array. What I'm actually doing is I'm actually calculating M, which is L plus R by 2. So this is exactly the middle point. And I query this. So while L is less than R, so right now L is less than equal to R. So I just query 1 in M. So basically I'm actually trying to find the number of zeros from 1 till M. Let's say this count was something X. So I just scan that X. Now, if this was X, the number of ones, as we saw, the number of zeros, so X is the number of ones, the number of zeros will be M minus X. Now, if this number of 1 is greater than equal to K, so I'll just explain why I'm doing this. So, an issue that comes is using binary search is that, let's say this was 1, and let's say, okay, so basically, let's say we had 0, 0, and 1 here. And let's say we had to find the count for the second k only. Let's say the k was 2. Now when we actually do m minus x will come 2, x will be 2 and m will be 4. So 4 minus 2 will become 2. We will see that this 2 actually matches with this k and we will say that this is the answer. But as you can see, this is not the answer. We need this 0. Now what I did is, if the count is always greater than, if the count is greater than equal to m, I just stored that particular value of m in answer, that this is one potential way, like one potential candidate for my answer, and I just decrease my r to r minus 1, and I just do again do the binary search from 1 to m minus 1. Okay, so what this is actually going to do is, this is going to give me the last occurrence when my answer was greater than equal to k. So basically the last index, sorry, the first index, so because if you see, for this index the answer will be 1, the number of zeros are 1, but for this index the value is 2. So basically what this line is going to ensure is that I always get the very first iteration, first occurrence when my answer becomes greater than equal to k, because if my answer is greater than equal to k, I'm decreasing r. So I'm just trying to like move on the left direction so that I can find the very first index of this value. Okay, so what this does is, let's say we had m minus x and this was less than k. If this was less than k, we know that we need to move in the right direction. So if this was less than k, I actually make L as, so I make L as m plus 1 and r remains the same. So m was already L plus n by 2. So basically L comes here and R stays here only. So the next midpoint that I'll consider is this one. And similarly, then I'll just see if my answer lies in the left direction or the right direction, and I'll just keep on going like this. So, and that is how you are going to solve this problem. Now, the reason why the queries work is because since in binary search the complexity is log n, so this while loop is going to run at most log n times. Okay, and okay, log n times, and n here is actually r only. So basically, log of, we know that n was actually 2 into 10 to the power 5. This value actually comes around somewhere around 19. Now, since this is 19, for every query, we'll have at most 19 queries only. So for every test case, we'll have at most 19 queries. And in the question, it is mentioned that we can actually have at most 20 queries. So that is why this solution works. I hope this is clear to everyone. If it is, I'll just move on to the hard part. Okay, let's open up the hard part now. Okay, hard part is a little interesting, so I'll just show how and why it is interesting first. Okay, so basically what they have done in the hard part is that, so let's say in this particular index only, they said that now t is not equal to 1, it can be anything. So basically and t is actually minimum of n or 10 to the power 4, and n is actually 2 times 10 to the power 5. So let's just assume that n was 10 to the power 5, then t would become 10 to the power 4. T would become 10 to the power 4. Okay. Also, one more interesting thing that they are doing is, whenever we solve one query, so let's say for t equals to 1, we solved that. When k was 2, we found out that 5 is the answer. That on 5th index, we had a second 0. Right. What they do after this is they actually take this particular index and they transform this index to 1. Now this complete array only has 1 0. So if k equals to, and they are also telling us that this k will always be less than equal to the total number of zeros that are present in that array at that moment. So when t equals to 2, they can only give us k equals to 1. If they give us k equals to 1, then the answer will be this index, that is 2. Okay, so let's say if this was 0 and 0, if k was 2, the answer would have become 4th index, as the second 0 is at 4th index. Now what they would have done is they would have actually changed this 0 to this to 1. Now when again they would have asked if k equals to, for k equals to 2, we would actually have to return k, that the answer is 5, not 4 now, because the 4th was turned into 0. So this becomes 5 now. Okay, cool. Now let's see why we cannot use the previous approach only. So okay, I'll just show the code of F1 again. So what I was doing in the previous approach, for every t, I was running this while loop. Okay, and we know that the complexity of this while loop was log of n, which is actually this, log of 2 into 10 to the power 5. So which is actually somewhere around 19. So let's say not 19, let's say this is 20 only. So if this is 20 and we are actually running this loop t times, so the total complexity becomes 20 into 10 to the power 4, which is 20 into 10 to the power 4. And if you see in the question, we are given that the maximum queries that we can run are 6 into 10 to the power 4. Now we need to somehow decrease 14 into 10 to the power 4 queries. How to do that? Okay. So basically this actually tells us that we cannot use the previous code only for this particular input. We need to have lesser queries. Now if you see, okay, let's say that this was a complete array. Let's say we first, okay, let's make it a little bigger. Okay, let's say this was the middle point. So first we would have actually found out the answer for this particular index. Then let's say a value was somewhere on the right side, we would have found out the answer for this particular index. Let's say it still thought that the answer was somewhere on the right direction, so it would have gone here, and let's say the while loop completed here, it said that I have the answer. Okay, so this was t equals to 1. Now t equals to 2. If you look at the code of F1, we again have L equals to 1 and R equals to N. So in the first iteration, this M is going to be the same. So we'll again check for this particular index only. But if you see, we already know the answer for this index. Okay. Now let's say for t equals to 2, instead of moving the right direction, it had to move in the left direction. So it moved here. And then let's say it moved somewhere here. And then we had our answer. So basically, okay. So in t equals to 2, we know that the maximum queries that we need to do is log n minus 1, because the first query is something that is duplicated from t equals to 1. So that can be saved. Okay. Now let's go on to t equals to 3. Now, if we go on to t equals to 3, you will see that the very first query again will be this index only. Okay. Now the next query will be either on the right direction or on the left direction. Now from t equals to 1, we already know the answer for the right direction. From t equals to 2, we already know the answer from the left direction. So again, this query will be, the second query also is something that we already know. So let's move on to the third query of this. The third query will be, let's say, will be here. So we can see that for t equals to 3, the maximum query that we had to do was log n minus 2. So let's just see. So let's just see how many queries we were able to save. So for t equals to 1, we saved 0 queries. For t equals to 2, we saved 1 query. For t equals to 3, we saved 2 queries. For t equals to 4, we again saved 2 queries. And if you'll see, for t equals to 5 also we'll have 2 queries saved. For 6 also we'll have 2 queries saved. But after this, when we move on to t equals to 7, we'll actually have saved 3 queries. 3 only now. Just a second. Okay. Yes, 3 queries. For t equals to 8 also we'll have saved 3 queries. So this 3, if you see the pattern, this 3 will now come what? 16 times. No, not 16. It will come 8 times. Then again for what? T equals to 14, we'll save 4 queries. Now if you see, this sum will actually be somewhere around 14 into 10 to the power 4. And this is exactly the number of queries that we had to save. Okay. And that is why we can actually use this approach. Now you would say that you're also given in the question that we, like, when we find the answer for t equals to 1, we actually have to change that particular index to from 0 to 1. So let's say we had this 0, and if the answer was 4th index, we had to change this 0 to 1. What we can actually do is, we can have a set and we can store all the answers of every place, of every index there. Whenever we actually change an answer for any index, so let's say we change the answer for index 4, we'll go on to index 4. Let's say this was index 4 in the set, and we will increment the answer of every index after that. So we'll actually increment. So let's say the answer for this was x and answer for this was y. We'll make this as, and let's say this was z. So we'll make this z as z plus 1. We'll make this x as x plus 1 and this y as y plus 1. The reason we are doing this because we were actually storing the count of ones. The count of ones after changing this 0 to 1 was increased by 1. Then similarly for this x also, for this index also, we actually increased the occurrence of 1 by 1, because this 0 was converted to 1. So this becomes x plus 1, and similarly for this index also, this becomes y plus 1. So that is all you have to do. So we know that. So basically, you just need to store all the previous answers, and whenever you get an answer for any test case, you just see which index it is, and all the stored answers after this index are incremented by 1. So I'll just show the code so that okay, just a second, you can see how it was to be done. There isn't much to change in this code. Okay, I'll need to copy. Okay, let's move. Okay, I'll show the code. Okay, okay, no, this is accepted only, right? Okay, so I'll just show the things that I changed. Okay. So if you see, this is actually very similar to the previous answer only. The things change are actually I have these two things. I have a set. In this set, I'm actually storing the indexes for which I already have the answer. So basically in this set, I'm actually storing all the indexes for which I already have the answer. And in the store, I am storing the values. Storing the values for the indexes. Okay. So basically for every index that I have the answer in this S, I'm actually storing the answer of that in this store. And we know that n is actually less than 2 into 10 to the power 5. Therefore, I took something just a little longer than that. Okay. So if you see, I have NAT, everything is same. What I did was, for so after this finding this m, I'm actually checking if I already have calculated this m. If I have calculated, this will give me an iterator which is not equal to s dot n, and I'll just pick it from store, because in store I'm actually storing all the answers for every previously like found array, found value. So if I already have that value calculated, I just pick x equals to store m. Otherwise, I go and make the query. I make the query, I scan the answer from the interactor, and then just store that particular answer into the sets that I have found the answer for this particular index, and I will not ever go and like find the answer for this index. Okay. Then the same thing, m minus x greater than equal to, so this is same. Now, after I exit this while loop, I know that my final answer is in this index. So basically, when I know that so basically this was 0, and I now know that my answer is this index. So what I do is I actually go into this set, and in this set I go into this particular index only, and I go. So basically, I iterate over the set after this index, and I just increment every value by 1. So this is the part where I'm incrementing, and then I just print the answer. Okay, I hope this is clear to everybody. Again, there wasn't much change in the code. It was all about the logic, like why this works. Okay, so I have after learning recursion, Shiva saying after learning recursion only I can come on backtracking and DP. So maybe Shiva, you can give a try to like binary trees. Maybe that will be helpful. Okay, okay. People in the chat, can you tell me if this is clear to you? Because this is actually a little important concept, and again widely used. So if you ever get an interactive problem, there is a very high probability that something like this will be done. Even if you are able to understand it after the stream, just try to like put out some time and like try to like just manually dry run everything in this and just see like why this is working and why I have done everything here. Because I like in my opinion, this takes a little time to write and like a decent understanding of why this is done like this way. Okay. I think everybody knows F2 as well now. Now, I myself was not able to like completely solve G. I have the code, but I was getting some errors in it. So I'll just like explain the approach. I do not have a solution to like a code to show for this particular problem, but I'll just show the code, like show how the problem is to be done. Okay, okay, cool. Okay, let's open G now. Okay, okay, okay. Let's move on to problem G. Okay. Okay. Also, like, can people in the chat tell me how many people want me to tell the solution of G? Because I'm not sure, like, many people will be benefited by it because I see mostly people here are from Div-3 only. Because, like, explaining this actually increases the length of the stream, which actually, like, stops people from watching the stream. Okay. Okay. So I'm waiting for people in the chat to tell me if they want me to, like, show the solution of G. Just give a hint. Okay. Shank says ये stream रहेगी और it will relate. No, this stream will stay on the channel. So even after a few days also or some hours, you can just come back to the channel and see. Also, people just subscribe to the channel and like the video so that I know like you are getting benefited from the stream. Okay, cool. So I'll just like show like how this is to be done. Won't be able to show any code or something. So okay. So Dima overslept the alarm clock, which was supposed to raise him to school. Dima wonders if he will have time to come to the first lesson. To do this, he needs to know the minimum time it will take him to get from home to school. The city where Dima lives is a rectangular field of an n size, each cell ij on this field and denoted by one number aij. The number -1 means that the passage through the cell is prohibited. The number 0 means that the cell is free and Dema can walk through it. The number x means that the cell contains a portal with the cost of x. A cell with a portal is also considered free. From any portal, Dema can go to any other portal, while the time of moving from the portal ij to the portal xy corresponds to the sum of the cost ai plus ij. Okay. So basically, what they are telling us is that, let's come on to this picture. So basically, these black cells denote that we cannot move into these cells. Moving from any one cell to any other movable cell which is free actually costs us W. W is a given cost. So W is the cost which actually we need to pay whenever we need to move from one cell to another adjacent cell. Okay. Then these red ones are actually passages. From any passage we can move on to any other passage, and this 1, 3 and 20 are actually the cost. So basically if I want to move from this 1 to this 20, so the cost of this will be 20 plus 1. So basically if I'm at this particular index and I have to move till to this 20, then I'll have to pay 21. Similarly, if I'm at this one and I have to move from this 1 to this 3, I'll have to pay 4. That is 1 plus 3. Okay. And so basically this is the start and we need to move till this destination, or I think it's the vice versa. So basically, okay. Okay, so basically this is the start, this D is written wrong. So basically this is the source and this last index is the destination. Okay, so let's look at the constraints first. So the constraint says that N and M are actually 2 times 10 to the power 3. So basically N cross M is actually 4 times 10 to the power 6. Okay, and W is 10 to the power 9. Okay, cool. And then we are given, okay, so -1 actually tells us that a cell is blocked, and other values denote if it is a tunnel or a normal passage. Okay, so basically if you see that, let's consider every cell as a node of a graph. So basically we'll have 4 into 10 to the power 6 nodes. Okay, now if you see, okay, and let's see like the number of tunnels we'll have. So let's say even if all the indexes are tunnels, then also the maximum number of tunnels, will be this, right? Okay, so a very basic approach for this would be, you can actually make all the edges. So basically, by all the edges, what I mean is, let's say you are at, okay, let me just draw this particular example. Okay, now okay, you can take a black. So this is blocked. This is also blocked. This is my start. This is my destination. Then, okay, do I have a red marker? Okay, I have a red marker. Yes. This is a tunnel of cost 3. This is a tunnel of cost 10, and this is a tunnel of cost 1. Okay, and again, this tunnel is also blocked. Okay, cool. Okay, I think I made a very good drawing. Okay, cool. So basically, what they want us to do is, we'll start from this particular index. So this is the starting point, and we need to reach this particular index. Okay. Where a very basic approach would be, we can actually make all the edges in this. By all the edges, what I mean is, okay, so basically we know that we can actually move in the adjacent direction. So let's say we are at this particular node, we know that we can move in this direction and in this direction. So we'll have an edge as this one and as this one. So let's see the total edges that we'll get. So for every adjacent edge, we'll actually have, so we know that there were n into m nodes, and every node will actually have at most 4 edges. So basically total edges will be n into m into 4. This is the total number of edges that we'll have, considering only the adjacent nodes. But we also have tunnels, and the maximum number of tunnels can be n into m only. Now from every tunnel we can move to every other tunnel. So basically we'll have, so the total number of edges that we'll be able to make is n into m square. So basically the total edges will be n into m square, and these values as well. Now we know that n into m is actually 10 to the power 6, so this will actually go out of range. If n and m were small, then we would actually have just made a graph. We would have made all the edges, and then we would just have made a Digikestra from source to destination, and we would be able to find the minimum path. But since this n into m is actually not in the range, we cannot use Digikestra. Now let's see what we can use. Okay, let's see the maximum number of tunnels that a person will use. Let's say that this 20 was actually 1 only. Okay, this 20 was 1 only, or let's say this was 20 only. So let's say we had any 3 tunnels. The first tunnel had a cost of x, the second tunnel had a cost of y, and the third tunnel had a cost of z. And let's say if we can actually move across all the 3 tunnels. So moving from tunnel 1 to 2 will cost us x plus y. Moving from tunnel 2 to 3 will cost us y plus z. Now if you see, instead of choosing this path, if you chose a path of directly from 1 to 3, you would have got x plus z. Otherwise, you paid x plus y plus z. So if you move directly from 1 to 3, the cost will be less. So what this tells us is that in a complete lifetime, we will only use at most 2 tunnels. One tunnel will be in which we go from starting, and the other tunnel will be that, let's say, so basically in this example also, what we are able to see is that we actually started from this index, we moved to this tunnel, and then from this tunnel we came into this tunnel, and then from this tunnel we went to D. So basically there are 3 paths. One path is from start to this tunnel, the other path is the path of this tunnel, and the last path is from this tunnel to the destination. So as you can see, there are 3 things to mention. So the first is start to tunnel. The second is tunnel to tunnel, which is nothing but x plus y whatever two tunnels we choose. And the last part is tunnel to destination. Okay. Now let's see if we can find how to find this. Now we know that at most tunnels are n into m, and we are coming directly from start to tunnel. So this can be actually, so to find this value, we can just find the, so basically let's say for this, we know that we can just find the distance of this tunnel from the start and then multiply that distance with w. Similarly, for tunnel to BFS as well, we can just take this tunnel and we can find the what? We can find the distance. So basically, the distance of this tunnel from this destination, we can find the distance and multiply it by w. So basically, this is nothing but distance times w, and similarly this as well. Now we are left with tunnel to tunnel. Now for this, we can actually have a BFS. Just give it. Okay. So basically all you have to do is you need to find these three values. After finding these three values, you just have to find the minimum. So basically you'll fix any two tunnel. So basically you'll fix any one tunnel and find the minimum value. I hope this is clear. Again, like if you're somewhere in Div-3, I won't like really recommend you to like do this problem at the moment. Just make sure that you're actually able to understand all the previous problems once, because like this arranging the sheep was a very popular problem. Again, the F1, F2 are actually very standard binary search problems. So like make sure that you actually understand the concepts why we're doing. Because the last part problem is actually a little bit into graph, so I won't really recommend that to someone of Div-3 to like do it right now. And as you can see, okay, G actually got lesser summation than F2. Okay. I hope this is the end of, I think this is the end of the stream now. And I hope many people learned many things in the stream. There were many interesting problems in this contest. So people just like this video so that I know that, like, you actually like the video, the stream as well. Okay, that's it for the stream. Bye.